Hey Emma,
What's up, Oliver?
I want you to see this image. I saw this on Twitter the other day. Apparently, it's grated garlic.
I saw the picture too. It's shocking because it turned this chemical green color.
Yeah, exactly. It's surprising to see garlic in such a vibrant fluorescent color, but even though it looks like this, apparently it's still safe to eat.
It may have a color that suppresses appetite, but it doesn't contain any harmful substances. The reaction happening with this garlic is similar to putting a rusty iron nail to turn black soybeans black. It's just a similar phenomenon.
So, the garlic turning green this time is similar to what happens when black soybeans turn black. Could you please explain it in more detail?
Got it! So this time, I'm going to explain the principle behind why grated garlic turns a chemical green color. First, let me briefly explain what happens to the garlic. When garlic is grated, it releases a substance that is responsible for its odor. When left unattended, the substance undergoes a transformation and then binds with iron. It changes into a vibrant green color.
When you put it that way, it doesn't seem like there have been any complicated reactions.
Yeah, I think it's pretty straightforward. All right, then let's take a closer look at the phenomena that occur in garlic. Garlic contains an amino acid called lectin.
Amino acids, are they the ones that are found in sports drinks?
While it's true that amino acids are included in sports drinks, they are actually different things. Amino acids come in various types.
I see.
You know, the amino acid called allicin in garlic is actually an odorless substance. However, when you grate or chop it, destroying the cells, it transforms into a substance called allicin, which is the source of garlic's distinctive smell.
Why does it transform into allicin when it damages the cells?
In order for allicin to be formed, the enzyme called allinase is required, and this allinase only works by damaging the cells of garlic.
Why does allinase only work when the cells are damaged?
That's because allinase produces allicin, which is a substance that garlic produces to protect itself. Allicin is the compound responsible for the distinctive odor of garlic, as I explained earlier. Herbivores and other animals dislike this smell. So basically, when garlic is bitten, allicin is the substance that is most needed to protect oneself. Allicin is produced when cells are damaged by biting. The enzyme that produces allicin, called alliinase, doesn't usually work.
I see. But wouldn't it be more reasonable to make allicin in advance instead of panicking when bitten?
No! Allicin is a substance that cannot be stored, so it cannot be kept inside the cells. The fact that allicin is the source of the smell means that it evaporates and reaches our noses. Feeling the smell means that the odor components have reached the sensors in our noses.
Allicin flies off into the air as soon as it's made, so you have to make it on the spot. That's why you have to make it in the moment?
Yeah, that's about right. Let's get back to the topic. When you grate garlic, an enzyme called alliinase is activated, and it produces a substance called allicin. And if you leave it alone for a while, this allicin will transform into alkyl sulfide compounds. Alkyl sulfide compounds are also substances that contribute to the smell of garlic. And alkyl sulfide compounds react with the trace amount of iron in garlic to turn green. It changes into a fluorescent green color. Whether it changes to green or not depends on the amount of iron in the garlic and the time it is left unused.
I see. I think I understand the gist of it. But it's strange that neither iron nor alkyl sulfide compounds are originally green in color. Yet when these two combine, they turn green. It's fascinating, isn't it?
Indeed. It's an interesting phenomenon. Compounds often undergo significant changes in color compared to their original substances. For example, copper in a 10-yen coin has a reddish hue to begin with, but when it rusts and becomes verdigris, it turns bluish-green, right?
That's true. By the way, I was just thinking, isn't verdigris, which is formed when copper rusts, highly toxic? Is it really safe to use such a dangerous substance in everyday objects, like a 10-yen coin?
No, the story that verdigris is highly toxic is a lie. In the previous textbooks, it was written that verdigris is highly toxic, but that's incorrect. In fact, research has proven that the toxicity of verdigris is not significantly different from that of common metals. After evaluating its wide-ranging effects on growth rate, survival rate, pregnancy, childbirth, and more in the human body, it is said that it has no impact on health whatsoever. Of course, I think it's a different story if you consume it excessively.
Oh, really? But why was it thought to be highly toxic?
Well, there are several theories. The most famous one is The verdigris color was considered poisonous, and there's a theory that the toxicity of arsenic, which can be found in copper as an impurity, was mistaken for the toxicity of verdigris.
I see. Indeed, blue does seem like a color that could be harmful to the body.
Well, it's wise not to put anything that looks like it could be poisonous into your mouth. By the way, garlic that has turned green doesn't contain harmful substances, so it's not harmful to eat. But the change in color indicates it's quite old, so it might be best not to eat it.
That's true, isn't it? When it turns such a vibrant shade of green, it's hard to notice if it gets moldy.
Yeah, you're right. By the way, the technique of causing a chemical reaction to make colors vibrant has been used since ancient times. This time, the garlic has turned into a color that could curb one's appetite. But in chemical reactions, we can enhance the color in such a way that it could stimulate one's appetite.
Wow, I wonder how it's been used so far.
The most representative example would be the Japanese umeboshi. Umeboshi turns red when red shiso is added, but it's not simply a matter of the pigment from the red shiso transferring to the umeboshi. It's actually the citric acid contained in the plum that reacts with the components in the red shiso, which results in its vivid red color.
I see.
Another famous method to make black soybeans completely black is to put rusted iron in it. Black soybeans originally contain a dark-colored pigment called anthocyanin. By reacting anthocyanin with iron oxide found in rusted iron, it becomes an even darker black. Furthermore, anthocyanin has a hydrophilic group, which means it easily connects with water. When boiled, it easily dissolves in water, but by binding it to the hydrophilic group of iron, it changes the molecular structure so that the color is less likely to dissolve in water.
First off, you mentioned that the phenomenon of garlic turning green and black beans turning black are similar, because both are caused by iron, right?
Exactly.
Thank you, Emma. I learned a lot this time too.
I'm glad you seem to be happy. So, let's summarize this time. The reason grated garlic turns green is because when the cells are damaged, a chemical reaction occurs. As a result, the newly formed compounds eventually bond with the iron. Let's take a closer look. Garlic contains a substance called allicin, which is responsible for this reaction. Allicin, by the action of an enzyme called alliinase, which starts to act when the cells are destroyed, changes into a substance called allicin. If allicin is left for a while, it changes into alkyl sulfide compounds, and when it combines with iron, it changes into a vibrant green substance.
Got it.
That's all for today. Thank you for listening until the end. I plan to explain everyday questions like this. So if you're interested, please come and visit again. Well then, thank you for watching.
Thank you for watching.